For a proof of justice-based blockchain, three types of entities are generally implemented: full, lightweight, and store. Full implies storing the entire blockchain locally. Lightweight implies storing block headers instead of the full blockchain data. And store implies storing the entire blockchain, and also provides historical blockchain data to lightweights upon request. In order to become a storer, a given entity must meet specific criteria, such as having enough available storage space to store the entire blockchain, having a score above a determined threshold, and the like. There can also be criteria to meet to be allowed to become lightweight. When an entity joins the network, it will send a transaction to say if it wants to be store, lightweight, or full. Other entities in the network will then check to see if it can be that type. If the entity wants to change its type, it will have to send the same transaction again, but this time with the new type. Otherwise, every time it does something in the system, it will be considered that it is of that type. In some implementations, entities that don't send the transaction are considered to be of type full by default. In some implementations, an entity could periodically need to send a heartbeat transaction, and if it doesn't send another one after a set amount of time, it would be assumed to be offline. In some implementations, other entities in the network will check on the entity from time to time to see if it is active. If the entity has been offline for a while, and it is a storer, entities could update their databases so that one or more other entities in the network can take its place as a storer if they meet the requirements. When a lightweight wants to retrieve some historical data, it will send a query to multiple storers. Storer will answer the query with the data requested if they have it. If not, they will respond with an error. The entity will then take the first few responses that were correct, which means they were not errors, and compare them against each other. If the data in these responses match, the data would be considered valid and truthful. Otherwise, the process is repeated until either all responses match or there are no more storers to query. In some implementations, a plurality of the storers would periodically sign the blockchain data so that it is standardized, allowing lightweights to only refer to one storer for a given historical data query, since the data returned by the storer would be co-signed, meaning pre-approved, by other storers. The amount of rewards a given entity gets is dependent on its type. Full entities would always get more rewards than lightweight entities, and the same goes for storers compared to full entities. For example, if a full entity acts as a generator, it would get 90% of the reward it would be allocated if it was a storer. The rest of the reward is divided up between storer entities. Comparatively, lightweights would get 80% of the reward it would be allocated if it was a storer. As such, entities would be incentivized to take more responsibilities and act ethically to earn more rewards. BB Inventions, high-tech research for curious minds.